Welcome, everybody. Please give a warm welcome to Nicole Zuckerman. She'll be talking to us about the glory of pdb.settrace.
Greetings. I work at Clover Health. It's a glorious place to work. This is my desktop and not the slides, though, so I should maybe figure out how that goes. I swear I checked this in the green room. There we go. Look at that. That's much better, right? So, hi, I'm Nicole. So as I mentioned, I work at Clover Health, which is a really great place to work, where we work on improving people's healthcare outcomes. And I work with some really great people there who are really super knowledgeable and whose opinions I respect. And some of them use print statements. And when I heard about this, I was like, are you kidding me? So I figured if they could use my PDB evangelism, then maybe other people could too. And so here you are. So I assume that means that you're interested. Thank you. So what is PDB? Come with me if you want to find out. Python debugger is an interactive source code debugger for Python programs. It's a great helper tool for writing and debugging code. It allows you, the fine developer, to run some code, pause execution in real time or in Postmortem. And once execution's paused, you can poke around at the code that you're running, which is pretty neat. So, how to use it? This is straight from the documentation, which I'll put a link to on the last slide. But you can always check it out because there's Wi-Fi in the room right now, and you can make sure that I'm not lying to you. There are a few ways to use it. So Python PDB MyScript, or in Python shell, where you import PDB, you import your module, pdb.run, your thing. PDB is useful in many ways, but we're going to focus mainly on one function, PDB's setTrace function. So what is this setTrace that you're doing an entire talk about? That's an excellent question. It's a function that's part of the PDB module. It allows you to identify where you want code execution to pause. It happens to be my favorite debugging tool ever. It takes no arguments. I wish I could take no arguments. And you can have multiple breakpoints in your code at different spots. So, here's how it looks. When I run this program and get to this line I've added in here, the import PDB, pdb.setTrace, execution will pause, and I'll get a PDB prompt, which you'll see in a minute. And in my shell, I can then examine variable contents, execute whatever code will help me identify my bug. And I cannot tell you how useful this has been in my life, although I'm going to try, obviously. But Nicole, I already have print statements. What more do I need? So being able to inspect variables and traverse the call stack during execution is a huge time saver. Yes, you're going to be watching this cat for a minute, so just be prepared. It's really useful and a huge time saver when trying to figure out what's wrong with some already shipped code. When writing new features, it helps increase my understanding anyway. It's particularly good when you don't already know exactly the root cause of a bug. And there's definitely benefits to using print statements or logging over interactive debugging. The low learning curve, the fact that everyone already knows how to print something. And logging is really good at identifying trends over time, or when your code is being executed by some remote process that you can't get a prompt in. But tools like PDB have really awesome benefits to recommend them. They are less time consuming because you don't need to rerun your program. They're really great for learning about the code quickly. And you can break on exceptions and conditions, which is a thing that maybe if you're super good, I'll show you at the end. So, what's so great about PDB? Here's what's so great about it. I'm going to tell you what I'm going to tell you, and then I'm going to tell you about it, and then I'm going to tell you what I told you, and it's going to be really great. Uh, so you can inspect contents of variables during real-time execution. You can traverse call frames. We're going to travel through execution order, and we're going to change live code during execution. And bonus, PDB comes with Python, so there's no separate install. It's with you everywhere you go. So here's my code sample. This is a toy program that's going to identify whether two strings are anagrams of each other. And the function is anagram will take two strings and return true or false. And this is just a vehicle for our lines with the breakpoints on them. There's one in each function, just because there's different things that I want to see at different points, and you'll want to see them too. So we have this other helper function to help construct a dictionary. The keys are letters in the string, and the values are the tally of occurrences of that letter. The first time through this helper function, we increment values, and the second time through, we decrement the values in that dictionary. And if a dictionary has all 0 values at the end, then the two strings are anagrams of each other. This is obviously the finest code I've ever written in my life. I mean, it has supercalifragilisticexpialidocious in it, so how could I go wrong, other than saying it wrong? So, task number 1, this is good stuff. First up, inspecting contents of variables during execution. It's that look right there. So I'm running this program from command line, and you can see the prompt that shows execution paused at this line, that PDB in parens. So now we can type the name of a variable that's already assigned, like input string 1. We can't do that with dictive letters yet, because that line hasn't been executed. So here I've shown the code around what we'll be executing, just so that you have some context, because if your brain is anything like mine, it's a sieve, and I definitely can't remember like 15 lines of code that we just saw 2 slides ago. Execution is paused at line 13, where you see that arrow, and you have a dictionary now, and you want to see what's in it at this point. So there's a couple ways to do it. You can do it the Python way, print. Depending on whether you're in Python 2 or 3, that'll look different. But you can print the dictive letters if you want. You can also just type the variable name in, and it will implicitly use PDB's p command. And you can see that I've also just demonstrated that the p command effectively has the same thing. So here's dictive letters. Although it's hard to see what's in it, I bet we can do better. So if we use pp for pretty print, this makes it easier to distinguish the keys from the values. And this is a trivial example, but it comes in super handy with large dictionaries or nested structures, like when an API gets some blob it's loading from JSON. Kind of like that one. Ah. Yeah. So, now we're going to traverse the frames in a call stack, and you'll be able to see what's in variables in the current frame you're in. We already know how to do that, but how do you see what's in other frames in the call stack? How do you even see what's in the call stack? So using a command called backtrace or BT, you can see all the functions that are paused, waiting for our current frame we're in to finish executing and return. You can see where we are in populate dict right there, but you can also see the function that called populate dict and so on. Our current context is at the bottom, and its caller is above that, and its caller is above that, and so on. So now we can not only see what's in the stack, but we can also go to any frame. If you type U or up, you can go up one function call. And you can also access whatever variables are in that context. So in this case, you can see that in populate dict, I have this variable input string, which is very cleverly named, but not input string 1. Once I go up once, I now am in is anagram, and I can inspect input string 1, and I no longer have access to input string. So Similarly to moving up, you can also move down the call stack. We don't have something convenient like backtrace to show us what's below, but we can go down into a function on the line that's about to execute. This won't execute any code. It'll just drop you down into the context of this line, but you can still inspect things and execute stuff if you wish. Step, or S, will also move you into a subroutine like D or down will, but step will also execute the first executable chunk on the line that you're on, if anything is executable. Some things don't have a down, so it'll just continue over to the next line. Down and up will move you, but step will also execute if it can. So here's an example of where step doesn't have a down to go to, but instead it just executes the current line and then moves on. This is like my favorite GIF because I love corgis. So now we're traveling through execution. I had an internal struggle between putting another Doctor Who Time Lord GIF here and this one, and you can obviously see which one, although a Time Lord would have been pretty compelling as we're talking about moving forward in execution, although you can't go backwards. Actually, yes, you can. So we're traveling through execution, and this is the code that we're executing. If we're paused at dictive letters and we type N or next, this one line will be executed. Before I type N, this variable hasn't been assigned, but after we hit next, we can now examine dictive letters. It's been populated. So, like next, C or continue will execute the code, but where N will only execute one line and will give you a prompt again, C says, resume normal execution, I don't need this breakpoint anymore. There's also Q or quit, which will leave all subsequent lines unexecuted. So if you're in the middle of running a test and you hit Q, your cleanup might not happen. So we've talked a lot about seeing the call stack, moving forward in the code, but how about just viewing your source around the line that you're currently on? There's L, or list, for that. You will, by default, view 10 lines. There's 5 above and 5 below the lines you're on, and I guess 11 lines because there's also the one you're actually on. But list is like a flashlight. You can move it around to view particular lines or just move forward in time. Like this one, list changes what it outputs on its own if you call it multiple times in a row. Even without any modifications, it will show you the next 10 lines. This is great for seeing a little further into the future without having to change windows or tabs. So you can see that I have lines 15 through 25 the first time I type it, and I'm executing line 20, and then I type list again, and now I'm seeing lines 26 through 34. So here's an example of giving list specific instructions about what I want to see. I've chosen lines 17 through 32 here. You can show any lines in the current file being executed, and if you pick a range that extends beyond the number of lines that are in the file, it'll just show you to the end. It won't give you an error. It's so nice of it. Okay, so this is where it really gets real. Changing code and seeing those changes affect the rest of execution. Note that this is not the part of the talk where I start live coding for y'all. That comes not at all during the talk, and 30 minutes from now when there's no one looking over my shoulder because I can't type when there's anyone looking. The ability to change live code on the fly allows you to find a mistake, correct it, and see how the rest of execution would go without restarting the process, which can save a lot of time and annoyance of making a change, rerunning the program, waiting to see if the fix worked, and then finding another issue one line later. You have to go make your successful change in 2 places, once in the PDB prompt and then again in your file, but I think that's a small price to pay for not having to go through that, there's an issue 1 line later feeling. So in this case, the line I've paused at, there's a variable letter that holds string s. And if I decide that letter should actually hold the string banana instead, I can reassign that here. And as code continues to execute, my change, banana, will stick. And clearly, this is a contrived example, but it's so useful when you find that you're referring to the wrong attribute of an object or the wrong index in a list. Plus, banana is an excellent letter. Another great use of PDB is that you can import a module while you're executing. So if you forgot an import in the first place, which happens to me all the time, or if there's some other module that will help you debug some SQL that you're creating, you can import things right there, which is incredibly powerful. So now we can see the rest of our code execute with our change without rerunning it. So this isn't exactly PDB, but there's a couple of tools that I probably wouldn't use as much if I wasn't using PDB. One of them is object dunderdict. It works with modules too. This is a small class that I made, and you can see a dictionary representation of it. Which, by the way, you should totally check out like URLlib or datetime sometime. I know that there's documentation, but it's so much more fun to poke at these things yourself. Another great PDB adjacent tool is dir mything. You can use it on pretty much anything and see what methods you can call on it. For example, we have this now instance, and if you call dir now and pretty print so it's easier to read, you get an enormous list of all the really useful functions that you can, or attributes that you can call on this. The list in the screenshot is just a slice of what's on now. There are so many methods that a full list on this slide would result in a font that's like impossibly tiny to read, even on screens that are this large. So, no tool is perfect, but if you know some of the surprises, they won't be nasty. So, one thing to note that is if a process running your code isn't running in a place where you can get a prompt, like some cron or celery task, or it's some remote machine that you can't get a handle on, PDB won't be immediately useful. There are workarounds that you can do to like run stuff locally, but in general, it's a little more challenging. All the commands that we've talked about have 1 or 2 letter shortcuts. So try not to name variables that would collide with a command. If I try to assign to p, for example, I get the syntax error. However, bang, whatever, will execute that thing as a statement instead of as a command. You can do bang any of the commands, but it can be omitted unless you're specifically doing something that PDB wouldn't know how to interpret if it was using the command version. So this isn't a gotcha. This is just a convenient reminder that the help command will tell you what commands are available, so you know what variable names would need the bang preceding, and also just a really useful reference about what you can play with. My final gotcha is the enter key. Hitting the enter key after a command will execute it, as you might expect, but hitting it again will re-execute that command, like bang bang in command line. So if you've stepped down into a function and hit enter again, you'll step down again. So this is really useful, actually, if you want to move forward like 8 lines in your code and you don't want to sit there going n, enter, n, enter, n, enter. But it can be surprising if you're not expecting it, and it can be surprising in the case of something like list, where it already gives a different output when I call it the second time. So, surprise, we're not only talking about set trace, but all the same tools that we use in set trace can apply to postmortem debugging as well. So I thought we'd just like give you a little bonus here. So far we've talked almost exclusively about setting a trace in a program at a particular point and running your program from command line. And that's great for if you know where you want to put the breakpoint, but what do you do if you're not entirely sure where the problem is, but you want to figure out what's going on? Postmortem debugging is great for exactly that. So here's the code sample that we're working with. I've taken out my set traces, but otherwise, it's basically the same, except that I've introduced one bug. I don't know who just said, huh, but your eyes are much quicker than mine would be. So if you import PDB and then run some code in a Python shell, you don't have to add the breakpoint to your file and then rerun your script, because that's a pain with long-running processes. We might as well be sitting around and waiting for code to compile at that rate. Instead, here we are in a Python shell. We've imported PDB, and we're running our code. An exception happens. If I do pdb.pm, which stands for postmortem, it will drop me into a prompt at the point that the exception occurred. So now I can investigate what went wrong at the time and in the context that it was happening. pdb.pm takes no arguments and will enter postmortem debugging of the last traceback. But if you use pdb.post_mortem spelled out, you can pass it a traceback object if you happen to have a handle on it, or you can pass nothing and it'll use the one that's currently being caught. I generally try not to have multiple tracebacks in my code, but if you need to say, I want to learn more about this one, here you go. Another super useful thing is breakpoints. So we've seen set trace and postmortem, but there's other ways to set a point in your code that you want to pause at. What happens if you're debugging some code and you realize that your set trace is in a less than helpful spot, or you want to fast forward to some other point in the code without hitting next forever? So this is where B or break comes in. You can add a breakpoint while you're running your code in a couple ways. So break 10 would put a breakpoint on line 10 of this file. And you can see that breakpoints are numbered. You can also give it a file name before the line number. And so here, you could break on a line that's somewhere else if that gets called. You can also give it function names to break as well. So you can also do conditional breakpoints. I want to break, but not until I get to the 10th time through this loop, or I want to break only if this value is true. Break by itself will also list all the breaks that are currently active and how many times that break was reached. And then when you're done with a break and no longer need it, you can get rid of it with the clear command. So you can do this by break number, clear the second breakpoint that I set. You can do this by specifying a file name, line number of a break. And you can clear all breakpoints by passing no modifiers. It will ask you to confirm first, though. So there's more to PDB and debugging in Python than we can possibly get to here. It's like a whole new world for y'all, and I'm so excited. You can check out customizing your own commands, for example. There's also IPDB, which has some of the bells and whistles of the IPython REPL. You can do pytest myfile -- PDB, and that'll drop you into a PDB session if a test fails, which is pretty cool because I break tests when I'm writing code pretty often. Mostly experiment. I've learned so much from this tool, and I've saved so much time doing it, and hopefully you will too. Thank you very much. If the first question is, do you like corgis? The answer is yes.
You hinted that there was a way to run time backwards. I assume you're referring to the postmortem debugging, or is there actually a way where you can, I mean, this is what I was hoping, where you can say, oh, I'm at line 20, gee, gosh, I wish I was back at line 15 and could try these lines over again.
I know that at least one thing that you can do is say, execute this line next. And the documentation is actually pretty good. It has, I'm pretty sure it talks about how to go back in time. I don't think you can unexecute the thing, but at least when you set breakpoints, as we were just talking about with break, it'll run through your thing end to end and keep executing it. So you're not exactly going back in time. In that case, you're re-executing all the stuff up until that point, and you could make new choices there. But yeah, you can like jump to line numbers if you want. I don't think that undoes what's already happened, though.
So I'm one of those terrible humans who has long debugged with print statements, and now that I've learned the glory of PDB, what would you say is the next thing that I should learn after this as you reform me away from using print statements to debug things?
Learn how to dance. What's the next thing you should learn? Personally, I'm probably going to check out PDB++ and the PyTest, mything, --PDB. These are just extensions of PDB, but they're ways that I think I can like really level myself up. So maybe you'll go on that journey with me.
Hey, so you mentioned celery tasks, and it's not possible to jump over the process boundary. But a case that tends to stymie me is actually async I/O. So I'll be at a breakpoint, everything will be going great, and then the scheduler will yank the execution context away. Mm-hmm. Is there some way to freeze that? Because it's obnoxious.
So I don't think that that's like anything that you can do with the core PDB. I know that there's this thing called remote PDB. I'm not sure if that would help in the case of async stuff, but it's maybe worth checking out.
Cool, thank you.
Yeah.
So if you've got your code sprinkled with these import PDB, pdb.setTrace lines, let's say that you're running your program and there's one that you're tired of looking at because you're like, no, that's not the problem, I don't want to see this anymore. If you had a breakpoint there, you could clear the breakpoint. But if you have the hard line that says set trace, is there a way to say, you know what, for the rest of this execution, stop paying attention to that, don't stop there?
That's a good question. I don't think I've tried to do that. I've usually just suffered through the, like, I lay in my bed that I'd made for myself. Yeah, I'm not sure. I would have to look it up, but now I'm really curious and I'm going to find out.
One of the problems I face when I use IPDB is I start a PDB session, I introduce some break statements as I debug. So then I find out, okay, what's wrong, and then I terminate that session. Then I restart my IPDB session. At that point, I wish I could get back all the breakpoints I had earlier from the previous session, plus also the commands I used in the previous session. So is there a way to get that history from the previous session?
Let me see if I can rephrase your question so I understand it well.
Mm-hmm.
So you're using PDB and you're going through and you put breakpoints in as you're doing stuff, and then you run the program the next time and you want your breakpoints back?
Run the program again, again try to debug it after making some more changes to my program.
I think that I think it probably depends on how you're running your program, but I think that once you do it again, at least from command line, that's definitely wiped out.
Right.
I wonder if you're already in a Python shell and you are running it from there. It's possible that PDB has that stuff in it.
Okay, I've not found it, so.
It's a good question, though.
Okay, cool, thanks.
Thanks for the talk. I would like to know if you know any advantages or disadvantages compared to external debuggers, let's say Visual Studio for Python tools for Visual Studio.
Do you mind saying that again a little slower?
I would like to know if you know advantages or disadvantages compared with other debugging tools like Visual Studio, like Python tools for Visual Studio.
Yeah, so I think that the PDB is like the vanilla version, and I know that the other ones out there like PUDB or like PDB++ have some bells and whistles. PDB++ has this like sticky mode that I think is pretty cool that classic vanilla PDB doesn't have. I don't think there's anything in particular that PDB does really well that these other ones don't also do very well. I think that they all like build on the base of PDB, but it is, you know, the original. But check out PUDB, PDB++. They have other stuff on top of what PDB has.
Thanks.
Yeah.
Thank you very much, Nicole.